All right, so we're starting by downloading the portfolio optimizer.xlsx. What is XLS? I'm sorry, not XLS. What does XLS mean? This is a really old example. I mean, I've been using the same file since before 2007. That's what it means. Okay, we've got that downloaded, and it's really a pretty good example. What's really surprising to me is that the code that I wrote back in the early 2000s is still working to pull data off of Yahoo. So that's pretty good. So let's talk about what we're going to do with the solver today. So the whole idea behind the solver is to say we have a problem that doesn't have an analytic solution. So we've got some kind of model, and we're trying to achieve something. We are trying to make one part of this model to be either get it to become a certain value, or to make it as small as we possibly can make it, or make it as large as we possibly can make it by changing certain other parts of the model. The idea is, if I'm trying to maximize profit, I could, play with the amount of advertising that I'm spending, the amount that I'm actually charging for the product, the various other things that I might do to reduce costs. And I can do all those, kind of play with those numbers and see what yields the highest profit. And so that's what Solver does. Solver is just really, really good at saying, change this cell, see how it affects our target cell, and then go, whoops, that was the wrong way. Let's change it a different direction. Okay, now change it a different direction. And it will do that thousands and thousands and tens of thousands of times until it adjusts and finds, the best solution that it can find. So that's the idea. It's not, there's no formula that we can write that would just tell us the answer. We've got to guess and check. Try this number, check it. Try this number, check it. How many of you ever done that? I mean, you did it this morning. Tell me your name. Dallin did it this morning, or this afternoon, just to solve the brain teaser, and it was a pretty simple model. But how many of you have ever done that in Excel where you get it up and say, well, let's try to make this number go a little different, change this part of the model, change. Have you just ever done that by hand? Yeah, okay, so it hasn't not that often. But so it turns out that there's a great tool for this. It's not built into Excel, it's an add-in. So let's start by making sure that we all have access to the add-in. So we're going to come to the add-in, not to the add-ins. What's add-ins? I don't even know what I've got going on add-ins. I got something funky going on add-ins. Let's not worry about that. Let's go to the data tab. So on the data tab, you should have Solver showing up right over here. How many of you, like me, don't have Solver showing? Okay, so let's go ahead and see how to add that add-in in. So I'm going to choose File, Options, here in Excel. And over here, there's an add-ins group over here in my options. I got options for add-ins, so I'll select that. And apparently there's all kinds of locations. I never know what this means, but there's the Manage Excel Add-ins. We'll click on Go right here. And then, hopefully, you've got the Solver add-in already loaded. It should be loaded. It comes with Excel, but you need to tell it, hey, I want to go ahead and add it in here. Then you should be able to say OK, and that should bring in the Solver tool right here on your Data tab. So you've got to have the Solver installed. So Solver is made by a company called Frontline Systems. It's not even made by Microsoft. It's an add-in by some other company. And the whole idea behind Frontline is they do optimization. And so they wrote this tool for Excel, and it was way better than Excel's tool. Excel had a tool built into it. What was it called? They've got one called GoalSeek. It's like the kindergarten of optimization. And so, if you've got a really simple model, GoalSeek you don't ever want to use GoalSeek, because if GoalSeek would work for you, you could do it yourself just by plugging a couple of numbers and going, yeah, I get it. So Solver is the one you want to use. Well, it turns out that Solver is, it's kind of, as far as Frontline is concerned, it's their low-end optimization. It's the one they go away. If you get into a situation, what, I need more out of optimization, then you're going to go buy a different add-in, probably from Frontline, to do everything that Solver does and more. But Solver itself is pretty powerful. You got to be pretty serious about it before you go, you know what, Solver just isn't working for me. So, but just realize it's from a different company. And what we're going to find, we're going to be recording code we're going to be recording ourselves using the Solver today. Today's all about automating the Solver. How many of you looked at code that Excel has recorded for you and gone, that really looks weird. I don't think it would have done it that way. Yeah, I think everyone has that experience. It turns out the folks at Microsoft who are writing the procedures that record the code, they're at least pretty consistent with themselves. When we start recording stuff with Solver, we're now working with a different company who's deciding what gets recorded when you use this stuff. And it's going to be even weirder. So just kind of get ready. Okay, so we're going to get there in a minute. But before we do that, let's go ahead and look at this workbook, what we have so far. So what this workbook does, in fact, this workbook was an example that I used to use for teaching user forms. And so if you click on the Add Tickers button, it should bring up some, one more thing. One more problem. Hopefully most of you, when you clicked on that button, it actually brought up a user form. Raise your hand if it brought up a user form for you. Yeah, that's most of you. How many of you got an error like I did? Just a handful. Let's see what we have to do to fix that error. It could be, this is a really kind of ugly one to track down, because you end up on a word like this, U-case, or right, or left, or something that you say, that's a part of the language. That's not, that's just the language. How could that possibly be an error? What does the error say? Can't find project or library for U-case. That's not a very helpful error. It turns out this is caused when we need a reference to a library that's not included. Since I just added in Solver, it probably isn't included here in this project. So I'm going to make sure my code is stopped, and I'll choose Tools, References, and I got to find, Solver is the one I was expecting kind of not to be there. The fact that it was already checked is a little bit troubling to me. So I'm going to say, okay, I'm going to close my project and open it again, and we'll try it again. Save that one. Yeah, remove, that's fine. Did any of you, when you opened that, Solver wasn't checked? Those of you that had the error? No? Well, this might be a really short class if this code won't run on this machine, so. You opened it, it's okay. So let's just try to click on that button again. Oh, look, my buttons are gone. Oh, there they are. Add tickers. Okay, good. So we don't really need this form for adding the tickers. All this was to, an example to work with some of the different controls on a user form. And all it does is takes whatever list you build in here, and then it writes it. Oh, F was already there. It writes it out to this. So this is really not necessary. But process model is. So you can tell where this really is an old example. It's looking at information from 1994 to 1999. So that's the window that we're pulling data from. Do you want to be investing based on performance from the late 90s? That's a really bad idea. What was going on in the late 90s? Yeah, you know what? Anyone could make money anywhere in the late 90s. Don't make investment decisions based on performance in the late 90s. Okay, but anyway, we'll just leave that data for there right now. In fact, you might want to take off Dell, because Dell is no longer publicly traded, so I'm not sure what will happen if we leave Dell on there. The historical data will be fine, but if you change it to more current data, which we'll do here in just a bit. Okay, so if we click process model, what this is going to do is it's not going to really run the whole model, but it's going to do everything it needs to kind of get this system ready to be optimized. We're saying, and here's the idea. The idea is I'm going to invest in these stocks. I've decided the stocks I want to invest in. Now I'm going to say, let's optimize that portfolio to minimize the risk and still allow me to achieve an expected return from that. That's the goal here. And so there's really a lot that needs to be done to build up this example, and that's what process model does. So I'm going to click on process model, and it should bring in a bunch of data from historical data from finance.yahoo.com, and then add several other sheets to build this model. But first then, let's take a look at this tab called Consolidate. So what this has is the average monthly change for each one of the stock tickers that we selected. So between the first and second month in the period that we're looking for, American Express, in 1 month, the stock price for American Express increased by 1%. It went up by 1%. The next month, it went up by 4%. The next month, it went up by 1%. Then it went up by 7% in 1 month. Is this a weird time? This is a strange time. Then it went down by 7%. There's kind of a correction there. Who knows what happened, but that one didn't last. But then it went up by 1%, went up by 0.8%, and these are all, kind of like that. Apple wasn't doing so well in the late 90s, kind of before the iPod. And anyway, but that's what these are. So these are monthly percentage changes in the stock price. That's the basis of this model. Okay, that information is then summarized on this summary sheet. So we've got mean. So when we say the mean here, this is now the average monthly increase. So on average during that period of time, American Express increased by almost 3% a month in the stock price. We'd be tickled if we can get 3% a year, today, but 3% a month is great. Apple went up by 2% a month, Ford, and everyone was positive. And then the standard deviation, that's how volatile the stock is. So we've got all those numbers, and then the question is how much variance is there around those numbers? Now then, what we're seeing here, we're also going to need to know something about how these stocks are correlated with each other. This is the whole idea behind optimizing this portfolio, is that we're saying, listen, we've got a portfolio because we don't want to put all of our eggs in the same basket. But we still don't want to put all our eggs in different baskets if those baskets behave just the same, right? So if I've got all technology stocks, they move together largely. In fact, if we look at some of these, we should kind of see high correlations. So in fact, what's the highest correlation here in this table? There's a 0.4. You see a correlation higher than that? Oh, Ford and American Express has a 0.5. So those are two non-tech stocks. What that means is that when Ford does well, American Express does well. When Ford does poorly, American Express does poorly. And in fact, that's really pretty highly correlated. I can explain half of the variation in American Express's stock if I only know what Ford stock is doing. Do we have we've got a negative correlation here. So between Apple and Costco, and also between Apple and American Express, that means that when Apple does well, American Express does badly. But, it's not very strong correlation. Oh, it's not too bad though. It's a 12% correlation. 1% correlation over here. So the correlation can be negative or positive. But the important thing is, in fact, if I have negative correlated stocks, that's a great thing to have, especially if they're both performing well across the period that I'm looking at, because that will allow me to diversify. So when one does poorly, the other one's going to do better. That's what I want to see in my portfolio. Okay, so that's the basis of these numbers. So questions on this? Let's then take a look at the model. So here's what we're going to try to optimize. So in the model then, what we have is, here's just the means for each one of these stocks, and then here's the weights. When we build this, the VBA that builds this just says, we're going to start by equally allocating this basket. What's the right word? This portfolio. So because I only have 9 stocks here, then we're each going to have 11% of the stock. 11% of the portfolio is going to go to each stock. That's just the default. We haven't optimized yet at all. It's just saying we're going to put some numbers there. Then this tells me that I've got a minimum and a maximum monthly expected return. Who's getting almost 5% a month during this period? Who is this? That's one of these. That's Microsoft. So this is a great time for Microsoft. Apple, not such a bad time for Apple, but it's not nearly what they've been, since the iPod was released. Okay, so someone explained to me why. In fact, we can do this for credit for class participation. If you're a finance guy and you've got this, why is this the minimum return I can expect out of this portfolio? Why is that the minimum return? This has shown me what the minimum and maximum expected return is. Anyone give me some insight onto why those numbers are there? What's the formula behind that or something? Go ahead. That's exactly right. This is just the minimum out of the mean. And this is just the maximum. So we're saying, even if I was to put all of it into Southwest Airlines, then that's the lowest I should expect to get. Now, what's the big caveat about all of this? We're looking at historic data, trying to predict future data. But saying if I was just looking at that historic data, that's exactly right. That's the lowest performance during that, of all these stocks, that's the lowest performance during that time period. And then again, we've got the highest preferred. So we're saying, no matter what I do, I can't expect to get more than a 4.8% monthly increase on my portfolio. And what would I have to do? How would I have to allocate my portfolio to get that expected return? All of it has to go into the highest performing stock, in this case, Microsoft. Okay, so now here's the idea. What we're going to have Solver do, in fact, let's just see if you can do it. So right now, here's my mean return. This is the average. This is the weighted average of the portfolio as it is. So we should be able to increase that. How would we increase that? Well, we've got to put more into Microsoft and take some out of Southwest Airlines. So let's do this. I'm just going to change this to, these numbers aren't very happy for me. These all got to sum up to 1. So I'm going to put ones in all, I'm going to put 0.1s in all of these. And then I'm going to have to put 0.2 in one of them to be able to get up to where I've got 100% of my portfolio allocated. So if we look right here, let's put in 0.2 in Southwest Airlines. 0.2. Okay, so now my sum of weights has gone to 1, which means we now have allocated 100% of our portfolio. 1% is going to Costco, 1% is going to, or 10% is going to Costco, 10% to GE, 20% to Southwest Airlines. My expected return right now is just below 3%. And if I was to change this, let's just flip these. Let's go 0.1 in Southwest Airlines and 0.2 in Microsoft. Now I'm up to 3.2% expected return on the portfolio. So that's the idea. What we're going to ask Solver to do is we're going to say, Solver, you play with these numbers. Change how we're allocating this bundle of stocks such that subject to two constraints. Well, subject to two constraints. The first constraint is, in fact, if I was trying to make this number to go big, what could I do? Yeah, put it 1,000 in each one of these. That number's going to go really big. So, okay, I'm not going to do that. So one constraint is I can't allocate more than 100% of my portfolio. And so that's what sum of weights. So the first constraint is whatever changes we make here, that's got to be 1. We'll probably tell, don't go negative. We're not going to short any stocks. So keep the numbers positive. And here's our second constraint. The second constraint that we're going to ask for is that here our expected return has to be greater than our required return. So this required return is arbitrary. The model just plugged that in for me. So let me just put in here, I'm going to put in 0.03. So subject to these two constraints, we're going to let you play with those numbers. But you got to make sure this is 1. However you change it, that's got to be 1. And this number has to be greater than or equal to 0.03. Now, the goal in all this changing is to try to minimize the portfolio variance. I'm saying, listen, I want to get at least a 3% return. And in so doing, give me as diverse of a portfolio as possible. That's the task. Okay, there's a question here.
You might have just answered it, but my question was this isn't a hard task. We could just put it all in Microsoft and earn the highest reward, but also have the goal of minimizing.
Yeah. So the question was, well, hey, this seems easy. Just put it all on Microsoft. You get the highest return. And the answer is, highest return isn't what we're trying to do. The highest return isn't the goal. The goal here is the minimum risk subject to an expected return. So we're saying, I got to have at least 3% return off these numbers. Make the risk as low as possible. Drive down the risk. Meet this constraint where I'm saying I need at least 3% return. Oh, and by the way, you got to allocate the whole basket. That's what we're going to ask Solver to do. And Solver's going to look at these 9 numbers, and it's going to start plugging and seeing how the model responds and making changes, and it'll do it it'll make thousands of changes, maybe tens of thousands of changes, in the half a second that it takes to run the model. Okay, so for how many of you is this the first time you've used Solver? So most of you have some experience with it. Okay, so are we ready to kind of use Solver for the first time? We should be set up and ready to go. If you're not, now's the time to let me know so we can get you going. Okay. So, number 1, the model that I want to have Solver work on has to be active when I say run Solver. So the sheet that's got the model has to be the active sheet. That is true whether I'm doing it interactively or my code is doing it. So that's kind of one of the gotchas. Most of the things we do with VBA, we could say, I don't care what sheet is active, manipulate that sheet. Solver, it has to be the active sheet. So we're going to have this in Solver. We're going to do this once before we record it, and then we're going to record ourselves doing it. Then we're going to take a look at the code. So on the Data tab, I'm going to open up the Solver window. So let's go ahead and get Solver configured. So step one is we got to tell it, we get one cell that it's trying to either maximize, minimize, or get as close to a particular value as possible. And so for us, it's going to be our portfolio variance. So the cell that is the target, the objective cell, is going to be portfolio variance, so that's D12. And we want to minimize that. So we're telling the solver, minimize, make that cell as small as possible. Now we've got to tell it what it's allowed to play with. So what cells are we allowed to change? This whole group, that's the weights. That's what you're allowed to change. And now we've got to add those two constraints. So subject to these following constraints. I'm going to choose add the first constraint. And the first thing I'm going to do is my weights. So my sum of weights right here has to be exactly equal to 1. If I say OK, it takes me back to the main one, and I can choose add again. Or if I just clicked add, it would add that one and let me do the next one right here. So either OK or add is fine here. The second constraint is right here. So here is my expected mean return. Has to be greater than or equal to, change this to greater than or equal to my required return. So here's the one where I'm saying I've got to have at least this much. And we'll say OK. Now, beginning with Excel 2013, I think, maybe 2010, we got this option right here, make unconstrained variables non-negative. Is anyone using a version of Excel that doesn't have this checkbox right here on your solver? Anyone? So you could get to it by options somehow, but it looks like everyone's got that checkbox there. We don't want anyone to go negative on what we're changing, so we'll leave that as checked. And then we have different engines that we can use to do the solving. I don't know enough to know why one is better than another, but GRG nonlinear is the default, so it's my favorite one. That's the one we're going to use. Then we'll just say solve. When we say solve, that's going to cut solver loose and say, all right, I'm going to now do what you told me to do, try to minimize portfolio variance by changing these weights, subject to these constraints. Tells me that solver found a solution. All the constraints were satisfied. Can you imagine making an over-constrained problem that it's impossible to meet all the constraints? Sure, that's possible. So, but in this case, we're okay, so our model's all right. So we're going to keep the solution. We can see that it's changed some of the values here. So we'll say keep the solution, and then let's take a look. Oh, I should have made note of what the portfolio variance was before, so we could see that it changed it. So here's what we're seeing is that it said, here's how you should allocate your stock. You really are getting at least 3% return, and we've driven this down. It seems like we've got an extra 0 here that we didn't used to have after the decimal point. I mean, it really has reduced the portfolio variance here. And so Solver's done a great job for us here. And if that's all we're trying to do, we probably wouldn't automate it. But why, what is it about a problem that says, you know what, we've really got to automate this. We've got to have VBA be the one who's setting up the solver. And what makes that important is if the size of the model changes. So if this is always going to be 9 stocks here, I can come in here, change all these values, run the solver again. I'll be in great shape. I don't have to reconfigure the solver. Just run it again. If the model doesn't change, I just run it again. But if the model changes between runs, which it would in this situation, right? I come back here and say, give me a couple more tickers in my basket. I now have a different size of model. I've got to go change the solver. I'd like to automate them. And so that's really the character. Whoops. That's really the characteristic that says that's why we want VBA to do this, is because I'm going to run multiple models and they're going to be of different size. They're not just new numbers in the same model, but different models each time. That's when we want to automate it. Okay, are we ready to record ourselves running at once and then getting to the code? Let's do it. Just so I can see it change again, I think I'm going to change my constraint from 3 down to 2. 0.0. Oh, that's lower than anything, so that's no good. Let's go to 0.25. So 0.025. 2.5% return. I'll turn on my macro recorder. We haven't recorded in a long time. Seems like the very beginning of class. Developer record. Macro 1, we're going to end up taking this code out and plugging it elsewhere in the model, so I'll just leave it as macro 1. Going into this workbook, that's fine. We'll say OK. This model is the active, or my model is the active sheet. That's great. Come to my data tab, invoke solver. I am going to start by clearing out all of solver. Here it is, reset all. So I just want to make sure that I'm going through this whole process. So number 1, let's get rid of the model that's there. Reset all selections, yep. And we'll go through that same process again. So this will now record us adding all this stuff in. So portfolio variance is going to be minimized by changing my weights. Add a couple of constraints, the same constraints that we had before. Sum of the weights has to be exactly equal to 1. My expected return has to be greater than or equal to my required return. Unconstrained variables are non-negative, so that should be it. I'll say solve. Goes through this process, I'll say OK. And now we've got different numbers were allocated here. Stop recording. All right, let's take a look at the code. So remember, that's always, every time we start a new recording session, it's going to make a new module. So even though I already had a module 1 here, I've got a module 2, which should have my recorded macro in it. All right, here it is. Solver reset. What do you suppose that does? That's the one that says, hey, whatever is there, blow it away and let's start again. It's really important to have that there because what you're going to see is that when we start adding constraints, we're doing solver add. If we don't reset the solver and we just start adding things, we're going to end up with adding constraints over and over and over again. So it's always important to have this first one here, solver reset. Let's look at the next one, solver OK. Seems like a strange name for it, but that's what it is. Let's see if we can understand it. Set cell equals D12. What does this do? What's this first argument, the set cell? Yeah, that's our goal cell. That's the goal we're trying to do. That's what we're trying to do something with. Second argument here, min-max value is going to be 2. And remember, the colon equals is what we use when we use named parameters. Most of the times when I do an example where we're passing an argument to a parameter, I just put them in order with a comma between them. The other option is to say, well, forget the order, doesn't matter. Instead, name each one of them, and that's what we're doing here. That's how it's recorded. So here's the name of the parameter. Colon equals says that's the value for that parameter. So the max min value is going to be 2. What does 2 mean? The second of these 3 options. So what you're saying is I got max, min, and value, so it must be min. That is a happy coincidence. So 2 means minimize, but it's not because it's the third one here, and that might actually be a safe way for this particular argument. But it's just that that's what 2 means. And yeah, 1 probably is maximized, but we would have to record it to be sure about that. Yeah, go ahead, question.
Was that what the next argument is for? Is if you choose the value, then you tell it the value you want it to be?
That's exactly what the next argument is. It is that if I chose here val, whatever that number is, it's probably 3. We'd have to record it to see. But if I said it's got to be a specific value, then that's when this argument is going to be important. I'm trying to make that go to exactly 0.5% or 0.5%. Then we'd specify that here. By change, this is the range that we're changing. And so, yeah, so you can see that this is going to be different depending on what we're dealing with. It turns out there's a nice little shortcut that I actually did when we built this sheet. So right when this sheet was getting built, I actually named this range. I named this range weights. Do you see it? So we can actually substitute that model with just the word weights here. So yeah, D12 has one. So D12 probably has a name, portfolio variance. We could put that in for that as well. That one's not so important because this one's always going to be one cell. But this range is going to change sizes. And so because the model is already naming that range after it builds it, then it'll make our life a little bit easier here if we don't have to actually go figure out what's that supposed to be and drop that in. Question?
Does it need to have the quotations around it?
Does it need to have quotes around it? I believe it does not. I think it'll work just like this. This is the name of the range. Oh, I'm sorry. You mean the quotes that are here?
Yeah.
Yeah, it definitely needs those. Oh. No additional quotes are necessary. This is just a string. It's a string argument.
Okay.
So we're using engine number 1, that default engine, the GRG nonlinear engine, and there's a description of that. I've never tried to delete those and see if it works without it. My guess is that it would, but we'll leave them there just fine. Okay, so now we're adding a constraint. Solver add, G7, the relation is 2. What does 2 mean? I think this is an equals. This has got to equal 1. We're going to see that we've got a little bit of a problem with this one, and we'll come back and fix it after the problem manifests itself. It's again one of these situations where the code that we record is a little bit deficient. But we'll see the error and we'll come back and fix it. And then same thing here, our expected return now has to be greater than or equal to our required return. Now this one's confusing. Does this line look familiar? Yeah, this is exactly the same as the statement before. Why is it here? I have no good answer for why that's here. Should it be here? No. Would it hurt to leave it there? No. I'm going to get rid of it. This next line looks kind of familiar too. What is it? Exactly the same as the other one. Get rid of it. It's just the macro recorder getting a little happy as you're working through this. We then say solver solve, and that's now the method that's actually going to say, go ahead and process the model. Okay, I'm going to take this block of code now that we've adjusted here, and I'm going to go ahead and copy it, and I'm going to bring it back into module 1. So we're integrating this code now into the existing code that we had to build this whole model out. Question?
So in default, it can be checked on the negative values, but I don't see any code that's...
Oh, interesting. So what you're saying is, yeah, maybe we should actually tell it to go to assume non-negative, or no, it was to make non-constrained variables non-negative. So yeah, I don't know specifically about that, so what would happen if it was set up, but the fact that we're saying reset, that's setting it back to its default setting, and then we probably don't need to deal with that. We could see that code, I'm sure if we were to change it to unchecked, we'd see what that setting is, and we could drop that in, but the fact that we're saying reset and then doing this, I think has got us covered. Okay, so I've copied this block of code. I'm going to come back to module 1 and we'll integrate this code. So I'm going to scroll to the top. I've got something here that just shows the ticker form, tickerform.show, that's fine. And now here's the main one that builds the model. So it clears old sheets. These are all sub-procedures down here we could go and look at. It builds new sheets. It gets the data. It summarizes. This is all the stuff that it's doing. And then we've got some others that are set up here that aren't yet running. Config solver and run solver. I'm going to uncomment those. And I'm going to come down to config solver. I'm going to paste that code in. So now, as we're running this whole thing, we'll start by clearing the old sheets, building new sheets, getting data, summarizing data, and then configuring the solver. That's where we left off in our prior running, right? Got everything summarized there, but the model wasn't yet configured. So now we're going to run config solver, which is going to reset the solver and then get it all configured up the way we want it to be. And we're going to move solver solve up here to run solver. So now when I blow this thing away and start again, it's going to say, okay, here's where you want you've added new dates. We're going to go pull all the data for those. You added new tickers. Go pull all that information, get the model set up just how we want it, configure the solver to do what we want it to do, and then solve it. That looks pretty good. Should we give it a shot? Why don't we just go ahead and run config solver right here and see how it goes. Seems like this is either going to fail when we configure it or when we run it, but I'm not sure. So I'm on config solver. I'll run that. The config works okay. Solver solve. Actually, this is the first time I've run this on 2016. It may or may not fail. I do think it's still going to fail. Solve it. So it's gone ahead and said that it solves it. I'm going to go ahead and keep that. We're going to see how to manipulate this box. But now let's go ahead and take a look at our code. Yeah, here's the problem. Sum of weights isn't 1. Sum of weights is 0.7. That's a problem. And the problem is kind of a quirk about the way the macro recorder records working with the solver. So let's go back and take a look at the code and let's see if we can fix that problem. It's right here. Here's where we're setting up that constraint to make sure that the sum of the weights is equal to 1. 2 really does mean equal, and we get some hint at the problem with the fact that the name of this argument is the formula text. Is this a formula? It's not a formula, it's just a number. Why does this have to be a formula? I do not know why this has to be a formula, but this has to be a formula. What's the easiest way to make a formula that returns 1? Equals 1. Actually going to make that a formula. Let me put a note on this one. Had to add the equal sign. Can I give you some intuitive reason as to why you've got to do that? I can't. That's just what has to be there. It works just fine in the model as a 1, but here in the code it's got to be equals 1. I'll run config, let's see. I got to run config solver again. Then I'll run solver. I'll run solver. We'll say okay to keep that, and let's take a look. Okay, and so now that's gone back and it's enforced that constraint. Our other constraint looks good. We're greater than or equal to 0.25. In this case, we're greater. But what does that mean? We really couldn't reduce the portfolio variance anymore. So we might as well get some more constraint here. Yep.
So why do we not have to have equal before the required return?
Yeah, so the question is, why don't we have to have the equals between the required return? And the answer is, I think it has something to do with the fact that this is a named range, and so it can't view that as just a constant. It has to view that as the results of a cell. I've never even tried to put the equal sign in here because I was so happy when I put the equal sign in the other one and it worked. I never tried anything else. I think it would probably work to take it this way. Let's try it. And it still gives us the same result. So my hunch is, as the reason that we don't have to have that here is because this is, Excel looks at that and says, oh, yeah, that's the result of a cell. That's a formula. Whereas this one is just a 1. It looks at it as numeric constant and it doesn't like it for some reason. So step 1, that's got to be I guess it can't be a constant. And there may be kind of some other things around it that I'm not familiar with. Okay, second problem that we have here is, do we really want to have the user answering that button? Well, let's take a look at this. I think I've already got the optimize button hooked up to run solver. Let's just run it again. Yeah, so we click optimize and it just invokes our code. What do you think? Do we want the user answering this box right here? Probably not, because our hope is that we can give this to someone that doesn't know the first thing about optimization. And if they look at this, they're going to scratch their head and go, I don't know what to do here. Solver found a solution. What do we do? What's the most likely thing that they will do? Well, they'll probably press OK. It's the default after all. But yeah, but there's no telling. We'd rather handle this automatically. Good news. We can do that. So that's just over here in solver solve. I'm going to hit the space here, and it should give me the IntelliSense help. Aha! There's a user finish parameter. User finish is a Boolean value. So do we want the user to finish this, or do we want to finish it by itself? Finish by itself. So user finish should be what? Yeah, you would think it should be false. But actually, that's the default. It's already user finish false. It has to be the opposite. So it's going to be true. It's like, to me, exactly backwards, but that's what we have to do. So user finish equals true. User finish means that the user does not finish it. Yeah, go ahead. Question.
So, like when you do the IntelliSense right there, and it popped up and it said user finish, the little yellow box.
Yes.
Where can you look to see the documentation behind a function like that to know if you should go true or false?
Well, the question is, when we come here and say, aha, there it says user finish, where could we possibly go to find out what that means? I mean, how did Professor Allen, we're so glad we took the class because you told us what that means, but what if you aren't there for us someday? Which is true. I'm not going to be, after, April 11th, I'm not going to be there for you. Actually, I still will be there for you. I don't want to be your first line of defense, but you run into an interesting VBA problem at work, you can't quite figure it out, feel free to shoot me an email, and I'm not going to spend a whole lot of time doing your work, but if something I know the answer to or is interesting enough to me to do a little research, I'll try to help you figure it out. I'll definitely respond to you. I don't know. Here's the only shot that's built in would be the object browser. So I'm going to choose View Object Browser. And I'm going to type in solver. I don't know if it's here or not. And hit enter. Nothing for solver. Oh, did I spell it wrong? Slover? Oh, good. There's nothing for solver. Config solver class. Yeah, it's not happening here. Oh, wait a minute. VBA underscore functions 1. This looks like all of the arguments from, this looks like all of the methods for it, so I think we're in good shape. So, library solver. So this one's in the solver library. This is in the solver. Okay, so we can see them in the solver library. They're in a class called VBA functions 1. It's kind of a weird class name. But here they are. So we should be able to find solver solve over here. Here's solver solve. And now the question is, does it tell us anything? It tells us the same thing we saw in IntelliSense. User finish and ShowRef. So we can come here and see some of the other things that are available for solver, but getting more detail isn't going to happen. So what's the next? So in terms of what's built into Excel, there's nothing more. What's the next place I would go? Google. VBA, Excel, solver, solver solve, user finish. There'll be someone griping about it. And we get some information. Question?
So this is solver, like, if it's not able to find a solution, will it also just save in it? Or like in the user's case, like, it'll do optimize, but it won't actually optimize it because it won't find a solution.
Okay, so what's going to happen if it can't find a solution? It's an overconstrained problem. Ugh, I don't know the answer to that. So let's just take a quick look and see if this next argument gives us anything. ShowRef. I think this ShowRef has something to do with actually showing some kind of report about this. So I'm not sure though. Yeah, so what is this going to do if it doesn't find a solution? I don't know. Yeah, that'll be something maybe we could take a look at after class or something. Okay, so now that we have solver solve set to true there, yes? It's a good question. Let's find out. The question is, what's my optimize button set up to run? I don't know. I mean, I wrote this in the late 90s or the early 2000s, so. Optimize, assign macro. It's just calling run solver. So yeah, all optimize is doing is calling run solver. It's calling this one right here. So your question is, why is it working? So the question is, hey, shouldn't you have to be calling config solver? And the answer is no. Once config solver is set up, the model is set up. Here's the boundaries that we're changing. Here's the goal that we're trying to attain. Here's the constraints. So now, if I change some of the data in that model, I can just say solve again. So if I change this from 0.03 to 0.031, I haven't changed which cells I'm allowed to work with. I haven't changed any of my constraints. I can just say solve, and we'll go through and solve. Let's go ahead. Let's just come look here. Data solver. We'll see that solver is still configured. Now, if I'm worried about the user coming in here and doing something like this, changing it to max, does the user change in the model? I don't know what's going to happen if I can do that. I found a solution. That's good. So now I've got the maximum possible variance. I don't want that. And at this point, my model is just going to say, yeah, maximum, great. It doesn't even look at the model. So if I was worried about that, I could make my optimize button do that. In fact, I could just say, just anytime we run solver, configure the solver as well. So that would save that. So yeah, I think it's a good point. How long does it take for me to configure that solver? A couple of milliseconds. And that's probably a safe thing to do because the user's got the ability to open up and change that solver. It doesn't really cost us anything to redo it, so you might as well. So that's right. If we look at how this works, is that when we run config solver, it gets configured right after we build the model. Once we know the size, we're saying configure the solver, and then we're good to go. So if in fact we're worried about the user modifying that model, then it would make a lot of sense to say anytime we run the solver, let's configure the solver as well. Okay. So we should be able to it optimized this. Oh, it put everything in Oracle. That was great. Yeah, that's not a very good. Let's try it again now that we've got that we're configuring the solver between, and it's giving us a reasonable distribution. So because that's now integrated, we should be able to go back and say, you know what? Let's look at for some more recent data. We'll take the same stocks, but let's go from 2000. Why don't we go from January 1st, 2000? We want to get past 2008 for sure. So let's go 2009 to today. What is today? 3:30. 3/30/2016. Now, who does it say we should invest in? Invest Microsoft, Apple. Well, anyway, everyone except Oracle and Southwest. Let's see if the world has changed. Probably has. Process model.
It will automatically update for you.
Should.
But you have to click the button.
I do have to click the button that says to build that. I'm not sure my model will have worked here. So model didn't work, and the reason the model didn't work was because that model, by the time I got there, that model was not the active sheet. So we've got to make sure the model's the active sheet. So let's go ahead and add that when we go to configure the solver. Sheets by the name of model dot select. I was rather expecting that to give me some IntelliSense help. All right, and I'm going to do that. Oh, I guess that should be enough to do it. So make sure that when I configure the solver, that's the active sheet. Give that another shot. Tickers, reprocess the model from scratch. Should bring in the data. And now it's given me a very different allocation. Still says don't invest in Oracle, but now it's saying Southwest Airlines can do something for me. Still says invest heavily in Microsoft, more heavily in Apple. It's tripled our investment. It's tripled our position in Apple. And that's how it goes. Costco. Oh, wow. Yeah, Costco is Costco? I don't even know if that's Costco or not, but some ticker. That's the one. Okay. Questions to this point? Yes. So the Yeah, so the question here is why use the name instead of the code name? If I use the code name of the sheet, which is sheet 14, then I don't have to worry about the user changing it. Sheet 14. We'll stand by just a second. Let me come back here. Tickers, process the model. Very nice. Model is now sheet 19. Why did the code name change? The code deletes the sheet and recreates the sheet. I could have this code, instead of deleting the sheet, recreating it, I could have the code erasing the data off the sheet and just using it. It's probably a better idea. The nice thing about this now is even if the user deletes the sheet, as long as the user doesn't delete the tickers sheet, they can delete the rest of these as they want, and we can rebuild the whole thing. So there's trade-offs there. But you're absolutely right that the user could change this name, and then I'd be in trouble. Could I write the code to figure that out? Yeah. I could write the code to instead of looking here, it could look for some other characteristic on this sheet, right? It could actually look at all the sheets and say, is this the sheet it's supposed to be? There's other ways to identify a sheet. Not nearly so easy as just going by the name. But I could scan across them and say, oh yeah, I recognize that. It says minimum return, maximum return. It's got, a named range on it that I'm expecting to see there and so forth. So there are kind of other ways around that. All right, the next part then of this problem, and another reason why I might want to modify this is say, well, listen, this is interesting because it gives me a portfolio at a particular distribution. I mean, at a particular required mean. But, what if I'd like to see kind of the efficient frontier for this particular basket? There are kind of there's a whole set of places I could be on this portfolio that are suboptimal. There are a bunch of places I can never get to on this portfolio, but the place where I want to be is, kind of right along this efficiency frontier, which I can define and I can see graphically just by saying, I want to see this not just at, don't just give me the numbers at one particular constraint on return, but let's move this down to kind of the lowest return I can expect and take several shots at it, see what it looks like at several places along my, from the lowest expected return to the highest expected return. And then if I chart that, I should be able to kind of see this efficiency frontier, which is a common way to look at a portfolio. So given a particular risk level, what's the highest, or given a particular required return, what's the lowest risk I can get? Change the return, see what the lowest risk is that I can get. And that's exactly what we have here on the frontier, this frontier sheet. So all this frontier sheet is set up to do, it's set up to say, we want to record the weights that were yielded by a particular required return and a particular deviation, standard deviation for that return. So let's take a look at the code to do this. So it's actually already written for us here. So there's a procedure called find frontier. And the increment says we're going to take this in bytes of 10%. It's going to start off by setting a minimum and maximum return as variables, just reading these off the sheet. And you can see here, I'm not telling it which sheet to look at. So which sheet's it going to be using? Whatever the active sheet is. So we better make sure that the model sheet is still the active sheet by the time we get here. And then we've got a for loop for x equals 0 to 10. And all we're going to be doing is we're going to be changing the required return to some formula. This is going to be the first tenth of the required return. Next time through the loop, it'll be the second tenth of the required return, 20%, 30% of the return, and so forth. And it's just going to run solver. It's going to copy the values over, and it's going to copy the results over, copy the weightings over, and then once it finishes that loop, hold on a second. Oh, here's the next. It finishes the loop. Then it's actually going to create a shape. It's going to delete any shapes off of there, and it's going to build a chart with that information. Whew. Yeah?
So you set the increment equal to 10. Is there any reason why you didn't use a constant instead of a variable for that?
Oh, yeah, good question. Why not use a constant for this? Because you're not changing this at all. I mean, it's just going to be running here. And the answer is, yep, I sure could have used a constant for that. Probably makes more sense. So I could come in here and call this const inc equals 10. Because you're right, I'm not going to be changing that value during the execution of the code. And just as stylistically, I like to put my constants before my variables. So put the constant at the top. The question is, what's the benefit of using the constant? And the answer is, when I have something declared as a constant, first of all, does it save any memory? No. Is it any more efficient in some way? No. So it's exactly the same as a variable. It's a name for a location in memory. The difference is that it's not allowed to change while the code's running. And so the reason that we use constants is so we can say, when I see that inc down here, I don't have to worry, has that changed? I know what that is. It's whatever it says in the code. When I look at the min return right here, minret, and I look at that minret right here, I don't have any idea what that is at any given point in the code. What is it going to be? It's going to be whatever it is depending on how it's changed before it got here. And so I have a little bit more thinking I have to do about this, whereas inc, we know, you know what, it's a constant, it's 10, can't change even if it wants to, I don't have to worry about it. So that's really the reason that we do it. And thanks for pointing that out. It really makes more sense as a constant, whoever it was that did that. Question in the back. Oh, okay, here's the question. So should we give this a type? Oh, I forget how to give a constant a type. As integer. That work? Yeah, so we could force it to be an integer. Is there a compelling reason to do that? Not really, because the interpreter is going to look at this, and it's going to go, oh, the value is 10. I could store that variable in a byte. Or I could store that variable in, it's going to pick a type to do it. Oh, so will it default to variant? The answer is no, it will not default to variant. There is no constant that's a variant. Can I even make it a variant? I don't think I can. I've never tried it. Yes, I can. I'm not going to do that. In fact, the whole idea behind variant, right, is we don't know what this data is going to be, so use that variant type because it can handle a lot of stuff. And that's never the case for a constant, right? For a constant, we know exactly what it's going to be for its whole life. So unlike variables, if we don't give constants a type, VBA looks at it and says, oh, I can store that variable, I can store that value in this amount of memory, and it picks a type for us. The reason you might want to pass it is that you might be setting it to a parameter that's expecting a string parameter. But even then, I think if it's a constant, it'll do the type conversion for you. So you might say, you know, I'm going to use this constant a lot. I don't want it to have to be converting from one type to another. I know the function I'm calling is expecting a long instead of an integer. And so I'll go ahead and make it a long, and that way it'll need no type conversion as it goes to that function. So there's a reason that you would do that, but it's a pretty small reason. Okay, so we should be able to find the frontier now. I'm going to go ahead and take find frontier. I'm going to uncomment find frontier so it'll run that when I run it. But I'm going to start off by making sure that my model is selected, and I'm going to go try to just run find frontier and see what it does. Hopefully, it's built me a frontier, an efficiency frontier chart. So now I can look at this, and I can see, all right, so when my required return is way down here at the bottom of what I can expect, this is how I should allocate my portfolio. If I'm trying to push it up here to get it the most, it says, hey, the only way you get the maximum expected return is what? To invest everything in forward. What's going on here with this one? Yeah, that's 6.5 times 10 to the negative 8. So that's 7 zeros. It's a decimal point, 7 zeros, and then a 65. So that's saying almost nothing. So it says, you know, your best so the best performing stock during this period is Ford. A little bit surprising, but that's what it is. And then here's the chart then that we've made. So this says, see, what do we have here? So our which one's variance? Could do a little better with this. 0.5. Required mean starts at 0.008. So here's 0, 0. So this is the required mean. So what this says, as we increase the mean, we can take on more variance, so we can get anything to the right of this curve. We could put ourselves anywhere on this, to the right of this curve. We cannot attain anything to the left of this curve. And of course, where we really want to be is pick a particular required return. We want to be on the curve. Anything else is suboptimal. So that's just what it's showing us is, that efficiency frontier. So those are pretty good examples where we got the solver. We can now run this, pick a different time period, come back to our tickers, pick a different time period. I don't want to start at 2009. I want to start at 2012. Process that model, and that should run all the way through, build the frontier, and everything. So now we've got very different. Now Ford's not the guy to invest in. Southwest Airlines is going to be the one who performs the best, and we've got a different frontier. So I've got a tool here, but I don't know. I just changed a couple of gears, and it's a very different story. So I don't think I'm going to be investing with this tool anytime soon. Someone who understands this a lot, the finance behind this a lot better than me, is going to advise me on this. Okay, so there's a question here. Yeah, go ahead.
So are you saying that curve is to maximize return, but maximize diversification?
So the question is, so what this curve is along this curve is where I maximize my return and minimize my diversification, and it's not quite that. What it is this curve says, listen, if you want a 2% monthly return, then it says the lowest risk you can take is right here. It's on this line. You can take on more risk, but there's no way to get less risk. With this required return, there's no way to get less risk. The amount of risk you've got to take is right here. So, I guess one of the things that this chart is kind of nice, does it make any sense for me to be down in here? Should I be taking a lower required return down in here? No, because look, I can get more required return without taking on any significant risk, any more risk. Here I take a little bit more risk in this jump right here. Here's where, when I start going after these kinds of returns where I'm taking on a lot more risk. So I can look at this and say, I probably want to be somewhere right in here is where I probably should be. And it depends on what my risk profile looks like and everything. So this says, what this chart says is, given a particular required return, what's the minimum risk I can use, I can get out of this particular portfolio. Okay, and that's why you would want to automate Solver, right? So here, we've really done two of the things that makes us want to automate Solver. One, we've set up a model that is dynamic. The user says, I want it to be this size. Great, we've got to automate the configuration of the solver. And now we've said, we want to do something with this model over and over and over again to build this efficiency frontier. Both are reasons why I would want to automate Solver. Questions? All right, that concludes this example.